Hello everyone, welcome to Code Enzyme, and in this video let's discuss this F problem from Codeforces round 920 division 3, and the problem name is sum of progression. And before starting this video I would like you to hit that like and subscribe button because majority of my viewers have not subscribed to my channel, and it doesn't cost you anything but it will help me a lot. So we are given an array A of n numbers and there are q queries of the form S, D and K, and for each query we have to find the sum of this sequence and in the we have to find the sum of this sequence. And let's see the constraints. We have n and q, okay, and ai ranges from this to this, okay, and then n is only going to n is still 2 into 10 to the power 5 and query is still 2 into 10 to the power 5, okay. So let's just write that down to make it clear. So n is going to 10 to the power 5 and queries are till 2 into 10 to the power 5, right? Since my q is 10 to the power 5, so definitely I have to process each query in log q time, right? Like for every query. So if you take what is the log of this? Let's just try to find it. So log 2 of 2 1 2 3 4 5, and we get something like 17. So I think we can approximate it to something like 30 to 60. So for every query we can have 30 to 60 operations, and we have to solve it in 30 to 60 operations. And if you see this sequence carefully, like as we increase our difference, the common difference, as we increase the common difference, the number of terms will reduce, right? So if I divide 10 to the power 5 by, let's say, something around 300, we have I think it is 33.33 something. So we have like that. So let's just take the root of 10 to the power 5. It is I think 316. So so I can say that if my common difference is greater than 316, I can just do a brute force. So if my common difference is greater than 316, I can simply brute force my answer, and the number of terms will obviously be less than will be less than 33, and I can find the answer in just 33 or even less operations if the common difference is greater than 316, okay. So that's what I was wanted to say. But let's say if my common difference is very less, let's say it is equals to in the order of 1 or 2, then the number of operations will be very large, right? And for this we want to calculate our answer. So now I will just create a new page, okay. So now we will discuss the approach. So I think so what do we want to find? Let's denote it by S. So S is equals to AS plus A of S plus D plus dot till I think it is, okay, it was D into 2, right? Okay, D into 2 plus dot A of S plus D into K minus 1 into K. Okay, so this is what we want to find for every array. We are given start index, the common difference and the K terms, okay. So let's denote let R equals to I think let's first solve it for D equal to 1, because it is very tough to generalize it like this. So first I will discuss the case for D equal to 1. So for now we are discussing the case for D equal to 1. So my S is something looks like AS plus 2 times AS plus 1 plus it goes on, then we get A of S plus K minus 1 into K, right? And let's say my S plus K minus 1 is R for now, okay. And now I'm defining one more sequence. Let's say my S0 equals to 0, S1 equals to 1 into A0, and S2 is equals to 1 into A0 plus 2 into A1, and this goes on. So from this I can say, now this is something I am defining right now. So I am defining a new sequence Si which is equals to 1 into a0 plus 2 into a1 plus dot 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 till I can say I into a of I minus 1, right? So this is something that I have defined. So this is something I will try to pre-calculate, and using this I want to try to find this summation. So let's see if I'm trying to use this. So what will be my SR? So if I say okay, what is my SR? SR is actually 1 into a0 plus 2 into a1 plus dot 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 till S of R into R, right? Okay, and then I want to say okay, what is my then there will be also be a sequence that what is my S. Let's not take S because it is creating a confusion here. I will take a different variable because that will be different. So let's take SL here, a of L plus 1 and L plus k minus 1, okay, into k. Okay, so now why did this happen? Okay, so let's say so what is my SL? SL is equals to 1 into a0 plus 2 into a1 plus dot 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 till S of L minus 1 into L, right? And obviously my R is greater than S, so this is actually much bigger subsequence, so it will be like S of L minus 1 into L plus S of L into L plus 1 plus dot 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 till S of R minus 1 into R, right? I think this is correct. Okay, and I think I have made a mistake here, like this. If this is like if my L plus k minus 1, let's not take it to be R, let's take it to be R minus 1. So if my L plus k minus 1 is equals to R minus 1, so my k is equals to actually R minus L, right? So I can replace this thing. I will just rewrite this, okay? So my SL is this, my SR is this, and I want to, from using these two, I want to create my S, which is actually equal to AL plus 2 times A of L plus 1, which is here, plus dot 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 till A of R minus 1 into R minus L, right? So what can I do is I can simply subtract these two equations, so these terms will get cancelled, and what am I left with? SR minus SL is equals to L plus 1 into SL plus L plus 2 into S of L plus 1 plus dot 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 till I am getting S of R minus 1 into R, right? So it is clearly I can see that SR minus SL is greater than S, right? So from this I want to subtract something to make this equal to this. So what can I subtract from? In here I can see L into SL is extra, so L into SL plus I want to remove L from here also, so L into SL plus 1 plus dot I also want to remove L here, so S into SR minus 1, right? And if I do that, I can say my capital S is equals to SR minus SL minus L into SL plus SL plus 1 plus till dot 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 plus S R minus 1, right? And this we can easily pre-calculate and query this using prefix sums, right? So if you want to find the sum of range, you can do this using prefix sums. So I can say capital S is equals to SR minus SL minus L times prefix sum of what should I say, R minus 1. Actually this should be this is the Rth term, right? So I can store it anyway, like you can do this anyway. So I will just this will depend on the type of indexing that I'm using, right? So let's say prefix sum of R minus prefix sum of S. Okay, so my prefix sum of 0 will be equal to 0, so I am using the 1 based indexing for the prefix sums. Actually I am using 1 based indexing for the summation also, so this is actually correct. So my capital S is equal to this equation. So I can pre-calculate my S values for SR, SL and the prefix sums, and then I can this is for a D equal to 1 actually. I have not generalized this, so for now my answer is equal to this. Okay, so now that we know the answer for D equal to 1, let's now try to generalize this. So if I have something like D equals to D, what will my S looks like? S will look like A of L plus A of L plus D into 1 plus A of L plus 2D into 2 plus that goes on till A of L plus N minus K minus D into K minus 1 into K, right? And I mean I can try putting this for R equals to R minus 1 and try finding the value of this here, but I think that will be a bit tedious for now. Actually let's try to find the answer for D equals to 2 first, and then I will try to generalize it. So let me just erase everything. So let's say my D equals to 2. Okay, so what will my S looks like? S will look like A of L plus 2 times A of L plus 2 plus 3 times A of L plus 4 plus, and it goes on till we have something like what will we have here? It will be like K, it was K, right? So K into A of L plus 2 times K minus 1. So we have K number of terms, and if you observe carefully that if my start element was an odd, like if L is odd, then the last element is odd plus an even number which is also odd, right? And if L is even, then my last this term is also even. So I hope you can see that. So the parity of all these, like if I take the index modulo D, it will be equals to same, right? So this is something you need to observe here. Okay, now what else can I say here? Okay, now just like for D equals to 1, I also want to define a subsequence here. So let's say my S of 0 is equals to 0. Like what will the parity, what parity can I get? Like if I am dividing by 2 by the Euclid lemma, I can say my remainders can either be 0 and 1, right? So I need to define some indexes here. So let's say my S of 0 is equals to 0, S of 1 is equals to 0, and if some other remainders I can get, I will also say equal to 0. And now my S of 1, actually S of 2 will be equals to 1 into, I'm just defining it. So S of 1 is equals to 1 into A0, and S of 3 is equals to 1 into A1. S of 4 is equals to 1 into A0 plus 2 into A2, and S of 5 is equals to 1 into A1 plus let's say what will it be? s of 1 will be equal to 2 into a 3, right? And this goes on. So in general I can say my s of I plus 2 is equals to s of I plus what is this, 2 upon 2, which is also 1. Okay, since this is I minus 2, so I minus 2 I upon 2 plus 1 into a of I. Like you can try to verify this. This is the equation for this s of I. Okay, now I want to solve this here, right? So I want to generalize my answer for this. So what will be my what will be the term with this last equation here? So I mean it will depend if the last term is it will depend if my k is even or odd, right? Because if my k I mean, how should I tell you this? Let's take an example here. Like, why not? Let's take an example. So let's say I want to find the summation from starting from L equals to starting from A2, or let's take A4 plus 2 into A6, 2 into A6 plus 3 into A8. Okay, so I want to find a sequence of 3 integers, 3 numbers in the array, which is starting from A4 and common difference is 2, right? So what will I do is I will say, okay, this will be equal to s of 8. I mean, I should take s of 10, right? Because s of 10 has s of 8 in it, minus s of something. What will that be? The one with the last element as A4 is actually let's take A4. So if I try to subtract A10 from A4, what will I get? I will get well, let's try 8 by 2 is actually 5. 5 times A 8 plus 4 times A 6 plus 2 times A what is that? 2 times A not 2 times, it should be actually 3 times A4 plus 2 times A2 plus 1 times A0, right? And from this I am trying to subtract S4 here, right? So which is equals to actually not plus, it should be minus of 2 times A2 plus 1 times A0. So these two terms will get cancelled. So let me just rub it. Okay, so from this equation I want to subtract something to make it equal to this value here. So what will I need to subtract? I think it is pretty obvious, like you can try to do it yourself, but okay, from 8 I need to subtract 5, right? 5 or 2, I think 8 I need to subtract 2, right? 2 times A of 8, then I need to subtract from A6 I need to subtract 2 times A6 minus sorry plus, and from here also I need to subtract 2 times A4, right? So I can say my S value is actually equals to S10 minus S4 minus 2, and 2 is actually equals to this, it came from here, right? So I can say it is actually equal to 4 by 2 times this A4 plus A6 plus A8, right? And this can be calculated using prefix sums, just like we defined a sequence here. Let me also define the prefix sum for you. So let's say my prefix sum of 0 equals to 0 and prefix sum of 1 equals to 0, and then I can say prefix sum of 2 is equals to A0, and prefix sum of 3 is equals to A1, prefix sum of what should I say here, 4 is equals to A0 plus A2, and similarly I can say prefix sum for at index 5 will be equal to A1 plus A3, and so on. Okay, so what is this equal to? This is equals to till a8. So I will have prefix sum of 10 minus the one with the last term with equal to not equal to a4. And what will that be? It will be equal to I think it will be equal to s prefix sum of 4, right? So prefix sum of 4. So I can say my s, the final equation that I am getting for s is s10 minus s4 okay, s10 minus s4 minus 4 upon 2 times prefix sum of 10 minus prefix sum of 4, right? And I can actually generalize this for any L to R. So S is equals to S R plus 2 minus S. Did I start with 4 or did I start with 2? I started with 4, right? So I will get SL minus L by 2 because okay. So then prefix sum of R plus 2 minus prefix sum of L, right? And this is for d equals to 2. So what will be my answer for d equals to d? Actually you can do this using trying to solve this from the start for a general d, but if I can just compare this with a general d, I will get s of r plus d minus s of l minus l by d into prefix sum of r plus d minus prefix sum of L, right? So this is my solution, final equation for a general D. Now let's try to code this up and try to find the answer. Okay, so let's say I have the square root factor. Let's take the maximum n as 1 2 3 4 5, so 10 to the power 5, 1 2 3 4 5, and my constant the square root factor will be equal to the square root of this number, which is equals to 316, right? Okay, let's remove these comments from here. Now okay, now for every test case we have single n and q, so let's take them as input. Now let's take the array c in a of I. Okay, and now I want to have some prefix sum values, right? So I need to have two arrays. So int let's say I am storing my prefix sum for the difference. So let's say n plus b. Actually I should take this something greater than 10 to the power 2 just in case. And also I want to have the summation value, right? So s value, prefix sum, and the that value, the summation series value that I wrote there. So s value of the for every difference, and then n plus b, right? And now for every difference, for every difference starting from d equals to 1 till d less than b, right? I will have to pre-calculate the value of prefix sum and the value of this this s value also. So for I from 0 to n, I define the values. So I have s of I, so capital S for d of I is equals to, actually s of I plus d, right, is equals to s of d of I plus not s, it should be capital S, plus a of I, right, times I by d plus 1. Because we had I by 2 here, it will become I by d for general equation. So s of I plus d is equals to s of I plus like that. And currently these values will be 0, so I will just reset them here. Okay. And similarly for my prefix sum for every difference, it will be simply equals to prefix sum for d of I plus a of I. So now that I have pre-calculated the values, let's say while q minus minus, for every query we have s, d and k, right? And from this I need to first get the right value. Let me just subtract my s index here. Okay, now if my d is less than b, then I have very few terms, so I can simply calculate my answer by brute force. So let's say int answer equals to 0 for I from 0 to n. Actually let's take it from 0 to k, and answer plus equals to s of a of I plus d times what should it be here, I plus d times 0, then we have d into something, right? Actually it should be s, not I plus d times I into I plus 1, and in the end I have to print my answer with a space. And in the else case I have to print s of d of not s, it should be capital S, s of d of r, right? I think it was r. So first I need to calculate my r, and this r will actually be equal to s plus d times k. So s of d of r, why s of d into k? Because I am taking r plus d here, so it will actually normalize it with a d. I can take d minus 1 into k and then write and then in here I can write r plus d, but so, or I can directly do s of d into k minus s of d of s minus it should be s by 2 times the prefix sum for d into r minus prefix sum for d into s with a space. And in the end I have to put a endl here, and I think now this should work. Let's try to run this and see if it is working. Oh, I forgot to take the input s, d and k. Actually there is a mistake here. This should be greater than equal to sign, because for differences greater than b we can brute forces, not for less than b. And this should be not s by 2, it should be s by d here. Let's try to run this and see if it is working. So now let's also try to submit this code and see if it is working. So yeah, sum of progressions and submit. And now it gets accepted. So if you are able to understand this problem, kindly like this video and subscribe to my channel, and I will see you guys next time. If you have any other doubts, you can comment down and I will try to reply to them. Okay, so thanks guys for watching till here. See you.